Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about basic polynomial operations. And we're going to name each polynomial by degree and number of terms. So, if I was given this polynomial, negative 10x, okay, so we have negative 10x here, okay. Well, how do we classify this? Well, first thing we're looking at here is, well, we see x to the first degree, right? That is our highest degree of x to the first power, right? So that's linear. We're linear, right? So it's a linear wave. X to the first power, that's the highest degree there. It's a linear. Now, what type of polynomial is? Well, there's only one section here. One section, so it's linear monomial. So we have a linear monomial. All right, and that's basically it. All right. Negative 10 r to the fourth power minus 8r squared. Okay? So we have negative 10r to the fourth power minus 8r squared. Our highest degree right here, our highest degree, we see r, right? The base there to the fourth power. That's going to be the highest degree right there, highest one, right? So the fourth power, we call that a quartic. So it's Q-U-A-R-T-I-C. Quartic. Right? So it's a quartic because that's the highest degree, the fourth power, right? We call that quartic. Then there are two sections, two parts, right? Two separate parts. We have negative 10r to the fourth power, that's one, and then 8r squared, and there's a subtraction between. That's a binomial too. So we have binomial. Okay? So we have quartic, binomial, and there we are. There we have our final answer. At first, this looks simple. It's just the number 7, okay? But we have to classify this as a polynomial, right? So 7 itself, there's no variable next to it, right? So we don't really have a degree. But 7 itself is a constant, so it's a constant. Now, how many sections do we see? We just see one section, so it's a constant monomial. Alright, 7 being a constant, boom, monomial, one section. Alright, so that's our 9a to the 6th power plus 3a minus 3a to the 5th power minus 4a to the 4th minus 3a squared plus 9. Okay, so I have 9a to the 6th plus 3a to the 5th minus 4a to the 4th minus 3a squared plus 9. Alright, what's our highest degree? Well, the highest degree I see with the variables is a to the 6th power right here. So we have a to the 6th power is our highest one. So there's nothing really special term, we just call it a 6th degree. So we have a 6th degree, alright, polynomial. Okay, so we have a 6th degree. All right, actually, that's this part. I kind of went ahead and don't do the next part, right? 6th degree is just there. Now, we have 1, 2, 3, 4, 5 terms. There's no special word for that. So that's just a polynomial with 5, number 5, not 5 terms. And there we have it, our final answer. We have a 6th degree polynomial with 5 terms. Negative 3n to the 3rd plus n squared minus 10n plus 9. Okay? So we have negative 3n squared plus n squared, or n to the 3rd, sorry, plus n squared minus 10n plus 9. We have to classify this. Well, our highest degree we see is to the 3rd power, right here. We have 3n to the 3rd power, right? So that's a cubic. So we have a cubic polynomial here, so a cubic polynomial. And how many terms do we have? Well, we have 1, 2, 3, 4 terms. So we have 4 terms. There's a special word for that, but it's called a cubic polynomial. All right, with, can you guess it? 4 terms. So we have a cubic polynomial with 4 terms. That's it. 7x squared minus 9x minus 10. Okay? So it's 7x squared minus 9x minus 10. All right? Well, first thing I'm looking at here is the highest degree. The highest degree I see is x to the second power, right? So we have a degree 2. We call that a quadratic. We call it a quadratic. Then from there, okay, we call it a quadratic. We have 1, 2, 3 terms. 3 terms there. It's a trinomial. So we call it quadratic trinomial. Okay? And there we have our final answer. So negative 4b. Okay? So we just have negative 4b. Well, our highest degree is the first thing I'm looking at here, and we have b really to the first power. When we just see that, that's our highest degree, that is linear. So we have a linear. Okay, it's linear. Now, how many terms do we have? Well, we have 1 term. Okay, 1 monomial. And there we have our final answer. Negative 9 plus 7n to the third minus n squared. Now what's tricky about this one is that they don't have the highest degree written first. When we see the highest degree, we see it's to the third power right here. That's where it is. All right, so since it's the third power, this is a cubic, sorry. A cubic. I almost said another part. Cubic. Okay. So we have a cubic polynomial here. All right, highest degree is 3. Now, again, different reason why we have 3. We have 1, 2, 3 terms, 3 distinct different terms there, and that is a trinomial. So make sure you see that the trinomial part, that 3, it comes from the 3 terms, while the cubic part is the highest degree was to the third power. This is our critical thinking question. So I'm not really naming too much here, but our critical thinking question here. So critical thinking. Is why is it impossible to have a linear trinomial with 1 variable? So why is it impossible to have a linear trinomial with 1 variable? Okay, well, the reason we have that, right, is that, well, if the highest degree is where it's linear, right, our highest degree is x to the first power, let's say. So something's to the first power, right, that's going to be the highest one. If there's any other x's out there, we would combine it together. So as we go down, the next one would be a constant. So the only 2 possible things, it could only have at most 2 terms. It's a linear and a constant. Right, linear and a constant. Okay, put that in there. Okay, let me just in case it's not, I'm just going to erase it here. So it's a linear and a constant. And so let's assume, okay, let's assume then that this is, let's say, an x, so we can see that, right? So we have 7x right here, 7x, and it's to the first power, right? If I had x to the second power, right, it wouldn't be linear, right? So the highest degree I could have is to the first power, and then if there were another x, let's say x, let's say 2x right here, right, to the first power, they wouldn't be separate because I could combine those first, right? So since I can combine those first, right, they would all be together. One would be actually 9x to the first power. And then we go down, so this is just an example again, to a constant. I'm going to have plus, I don't know, 8. So now we would have a linear constant, and at most could have is 2 terms. Now I could have other constants there, but again, I would have to bring them and simplify them together, all the constants together. So again, that's why it's impossible, right, to have a linear trinomial with just one variable. Okay, we would have to have, it couldn't be a trinomial. It would have to, at most, could have 2. All right. So we have 4m to the 4th power minus m squared. Then plus 5m squared plus m to the 4th. Okay. So what I want to do is I need to combine our like terms. First thing is always I look within each parenthesis. Nothing to combine in each one. So we can imagine like the parentheses are gone now at this point, right? We simplified as much as we could inside the parentheses. Now let's combine our like terms. Well, we have 4m to the 4th and m to the 4th, right? So we have plus 4m to the 4th and plus m to the 4th. So with that, right, we can almost rearrange this. So if you want to see it like this, 4m to the 4th plus m to the 4th, okay? Then we have our next degrees are the m squared and a 5m squared, or negative m squared. So we have a negative m squared, and then we have a plus a 5m squared, okay? So we have all of our like terms kind of next to each other, right? All the degrees there, okay? So now we can simplify and combine them. 4m to the 4th plus 1m to the 4th is a 5m to the 4th. Then we have a negative m squared, and I like to see this as like plus and negative like this, right? So subtracting m squared, we're adding a negative. That's the way I like to see it. Well, negative m squared plus 5m squared is a positive 4m squared. So we have plus 4m squared right there. And there we have our final answer, 5m to the 4th power plus 4m squared, okay? 5x to the, or plus x to the 4th, excuse me, minus 3x to the 4th plus 4x, okay? So what I want to do, okay, first I'm going to bring my, or look inside each parenthesis, right? And I want to see if I can simplify. Well, nothing to simplify here, and nothing to simplify here. They're not like terms, okay? So then what I need to do, all right, is I'm going to rearrange my like terms. Now, before actually I do that, I see this minus sign, and this is what I like to do. I like to distribute that minus sign around. So when there's no like terms in here, I don't need the parentheses anymore. So I have 5x plus x to the 4th here. Then, from there, I can distribute this minus sign around. So we have minus 3x to the 4th, so we have minus 3x to the 4th here. And make sure we distribute that minus sign to both parts. We have minus 4x, okay? Now if you're like me, I like to see this as plus a negative, right? So I have plus and negative, right? That's the way I like to look at it. So now I'm going to bring my like terms together. Well, my highest degree is x to the 4th, right? I see the 4th power. So let's go rearrange that. We have x to the 4th here plus a negative 3x to the 4th. And sometimes I put little dots underneath to show that I've brought that term over. Now the next highest degree I see, well, I don't see a 3rd degree or a 2nd degree, but I see a 1st degree, 5x and minus 4x, right? So we have plus 5x, brought that term over, and then we have plus a negative 4x, okay? Brought that term over. So from there, we have one more step. We're almost there, right? Let's combine them. X to the 4th plus a negative 3x to the 4th is a negative 2x to the 4th power, all right? And then 5x plus 4x just comes out to be, well, 1x, right? So a positive 1x. And there we have our final answer. We have a negative 2x to the fourth plus x. 5 plus 7x to the third plus 3x squared, that's in one parenthesis, plus, second one, negative 12 plus 5x plus 6x squared. Okay? Well, first thing I want to do here, okay, is I look within each parenthesis to see if I can simplify within it. All right, any like terms. No like terms here, and I don't see any like terms here. So now I'm going to rearrange my highest degrees first. Okay, and we don't really need since that happens, we don't need the parentheses really anymore. Highest degree I see is to the third power. So I'm going to bring that down. 7x to the third power. And I put a dot underneath showing that I've brought it down. Next highest degree I see is to the second power. We have a 3x squared right here, and then a 6x squared. Okay. Next highest degrees that I see is just the x, right, to the first degree, so we just have a plus 5x right here. Okay. Then I see, well, we have a constant 5, and then a negative 12, or plus a negative 12. Okay. So we have a negative plus a negative 12 right there. Okay. So now I just have to simplify, right? Well, there's nothing x to the third power besides the first ones, right? So we just bring down the 7x to the third. We're good. Now, with the x squares, we have 3x squared and 6x squared. We combine that together to be a 9x squared. Okay? Got those. Now, we have the x's. There's only one x, so we bring down the 5x. Okay? Right there. Then lastly, we have a positive 5 and a negative 12, which comes together to be a minus 7, right? And there we have our final answer here. 7x to the third plus 9x squared plus 5x minus 7. 4 plus 3x squared plus 8x to the third power plus, in another parenthesis, negative 7x to the third plus 12x to the fifth plus 6x squared. Okay? Alright, so with this, right, I just need to really combine my like terms and go for it. So, first thing I look is within each parentheses, can I simplify anything? And the answer is no. There's nothing within each parenthesis that I can simplify, combine. So I don't need the parentheses anymore, and now I get my highest term, highest degree. Well, highest degree I see is to the fifth power right here, right? I have 12x to the fifth, so I'm going to put that out here front, 12x to the fifth power. And again, I put a dot underneath showing that I've brought that down. Next highest degree, well, I don't see anything to the fourth power, but I see to the third power. We have 8x to the third plus 8x to the third right here. And then I have a negative 7x to the third. So plus a negative 7x to the third. Okay, got that down. Then after that, highest degrees will be the second power. So we have a plus 3x squared right there. And then 6x squared right there. Then from there, what I need to do is just bring the last one down, which is just the constant, which is 4. And I believe now I have everything brought down. We're good to go. So now I need to combine my like terms, right? So there's nothing to the fifth power, so that just comes down 12x to the fifth. But then I see to the third power, so I can combine this, right? 8x to the third plus a negative 7x to the third is just a positive 1x to the third. So we have plus x to the third right here. All right, got those. Now we deal with the squareds. 3x squared plus 6x squared is a 9x squared. Got that? And then we just bring down the plus 4 by itself. And there we have our final answer. 12x to the fifth plus x to the third plus 9x squared plus 4. All right? 13m to the fourth plus 2 plus, another parenthesis, m to the fourth n squared plus 2 minus 2m m to the fourth minus negative 13 m squared n to the third plus 5 m to the fourth. Kind of a large, large polynomial here, okay? So what I want to do is, first thing as I look within each parenthesis, hey, is there a way I could simplify this? Well, I don't see any like terms within each parenthesis. So my next step is I actually like to distribute this subtraction sign to get everything positive, and then we kind of get rid of all the parentheses. So let's do that. We have 13 m to the fourth plus 2 plus m to the fourth n squared plus 2 minus, right? And let's make this a plus and negative, actually. I like doing that. Plus a negative 2m to the fourth. Now we're going to distribute the subtraction sign to both parts here. So distribute the subtraction sign. Negative and a negative make a positive. So we have a positive 13m squared n to the third. And we distribute the next negative sign over, and we have plus a negative here, plus a negative 5m to the fourth. Okay. So the way I'm going to organize this, and it's really up to you how you want to do it, and in the order here, let's go put the ones that have the fourth, m to the fourth power, and n squared. Okay, so let's put those first. All right, let's go dealing with the highest degrees together, combined in a sense. So do I see anything else that has m to the fourth, n squared? I don't see anything, so I'm going to mark it, knowing that I'm using it and putting it here first. So I simplified this part already now all the way as much as I can, this first part here, right? So the next one is like, okay, what's the next things we're going to do? Well, the next combinations that I see are just the m squared n to the third, okay? So I see that combination. I don't see anything else here that has this combination, this like term in a sense. So I'm going to mark it. I'm going to put it right here. I have 13 m squared n to the third. Okay, I guess I can do it like this, right? N to the third. There we go. Okay. Then from there, okay, mark that. Let's go to the next one down the line. Next thing I see a lot with the fourth power. So I'm just rearranging here. I'm not necessarily simplifying together. So let's go bring this one down. Plus 13 m to the fourth. Got that one. Okay, put a little dot showing I brought it down. Next one I see is this one, right? Plus a negative 2m to the fourth. Got that down. And then the last one here, the negative 5m to the fourth. So plus a negative 5m to the fourth. Brought that down. Okay? Next thing I'm not forgetting, but I need to bring down are my constants. Last two ones are the 2's right here. So we have 1, 2. Bringing that down. And plus another 2. Bringing that down. And I definitely recommend taking your time with this, okay? Putting your dots where they need to be and slowing down, okay? Make sure everything comes down. Doesn't matter how fast you do an answer. If it's wrong, right? So you need to, understand how to take your time through it, right? So now let's go simplify. Well, luckily the first parts here have no like terms. So I'm going to bring that down just for n squared plus 13m squared n to the third. Okay, but now I have three terms that have m to the fourth power, so we need to combine them, all right? So 13 minus or plus a negative 2m is in positive 11, right, m to the fourth, right? And then we subtract a 5, right, plus a negative 5 there, so we have 6. So we have plus a 6m to the fourth. That's left over when combining these three. And then, lastly, we have 2 plus 2 is 4, right? So now we have our final answer, our simplest form. I'm circling it, and there we have m to the fourth n squared plus 13m squared n to the third plus 6m to the fourth plus 4. Negative 10m n to the third minus 4n to the fourth power minus negative 2n to the fourth minus 7m n to the third minus 6n to the third power, and that's one other parenthesis. Subtract my last parenthesis, 5n to the third plus 6mn to the third power. Okay, well, first thing I like to do is, again, I look within each parenthesis. Is there anything I can combine? I don't see anything within each parenthesis that I can combine. No like terms there. So then, what I do in my next step is I distribute all my subtractions within each parenthesis, and then anything that's a subtraction overall, I make it a plus and negative. I find it's easier to rearrange and deal with that way. So, start here. Nothing really here to do, so I just have a negative 10 m n to the third. Then this one I bring down, I make that plus and negative. So instead of subtracting 4n to the fourth, I'm adding a negative. So we have plus and negative 4n to the fourth here. Okay? Now we need to distribute this minus sign to both parts, or 3 parts actually. So subtracting a negative 2n to the fourth, same thing as adding a positive. So we have plus a positive 2n to the fourth. Do that again to the next part here. All right, subtracting. So again, double negative plus a positive 7m n to the third. And then lastly, go over here, distribute the minus sign to both parts, plus a positive 6n to the third. Okay, one more parenthesis to deal with. I distribute this minus sign, and we have plus now a negative 5n to the third. And lastly here, again, plus a negative 6m n to the third. All right. So now I look and see, okay, how can I rearrange this? And the way I like to do it is, okay, look and see I have a combination of a lot of mn to the third powers. I have 1, 2, and 3 of them. Okay, so I'm going to rearrange and put those first. I like to use my dot method under each one when I rearrange it, showing that I brought it over. So we have a negative 10 mn to the third. Brought that one down. Next mn to the third power is this one, 7. So we have plus 7 mn to the third. Bring that one down. And the last mn to the third that I see is right here. We have plus and negative 6 mn to the third power. Then my next highest degree that I see, all right, there's no combinations of m and n's, they're just n's, right? So the last one's, next one I see is to the fourth power as the highest. So we're going to bring that down. So we have plus and negative 4n to the fourth power right here. Bring that down. Then the next one to the fourth power that I see is right here. We have plus 2n to the fourth power. Okay. Then from there I see the next highest is, that's all the fourths, so we have to the third power. So we have plus a positive, right? 6n to the third. And you don't need to keep writing plus a positive. I don't really need to do that, but I did. Then the last one I see here is bringing down is plus a negative 5n to the third. Now it's always good to double check we brought everything down, which we did. Okay, great. So now we're going to combine our like terms to simplify at the end. So little tricks I like to do here is, instead of just going always left to right, we have our 3 here, 3 like terms of mn to the third power. Well, 7, look at the coefficients, 7 and negative 6 are just positive 1, right? So essentially we have a positive 1 mn to the third right here, add that with our negative 10 mn to the third, and we have negative 9 mn to the third power. Got that down. All right, bringing it, so we got that. So the next ones here we have to the fourth power. Well, we have 2 of them. We have negative 4n to the fourth and a positive 2n to the fourth, which is a minus 2n to the fourth. So we have a minus 2n to the fourth power right here. Okay, got these 2. Then we have to the third power. Well, we have 6n to the third, positive, and a minus 5n to the third. Combines to be a 1n to the third. We don't need to write the coefficient 1, so we just write positive or plus n to the third power, and you never really write that coefficient. So now we have our final answer here of 9 mn to the third power minus 2n to the fourth plus n to the third power. Two n plus 3 times n minus 2. Alright, well, what I like to do is first look within each parenthesis, anything we can simplify. No. Now we take all parts of our first parenthesis and multiply it by all parts of our second parenthesis. So I draw arrows to do that. So we have 2n times this n gives us a 2n squared. Then we multiply this 2n by this minus 2, and we have, so we made plus and negative, we're just minus, but plus and negative here, right? So go to negative 2 times 2n is a negative 4n. Then we continue that, or we finish the 2n being multiplied to both parts. So now we have to deal with the 3. So 3 times n is just 3n, and 3 times a negative 2 is a negative 6, or plus a negative 6, however you want to see it, right? Okay, so now we've done our distributing right here. So now we need to simplify what's left. Well, the only two like terms here are the minus 4n and the 3n. So we bring down the 2n squared. Then we add here, well, we maybe not add, right? Negative 4n plus 3n is a minus 1n, right? We don't write the minus 1. When it's 1, we just leave it there. So we just write the minus. So minus just n, right? And then we have minus 6. And there we have our final 5v minus 1 times 4v plus 3. Okay? Well, what I want to do is multiply all parts of my first parenthesis by all parts of my second parenthesis. Okay? So we did start with the 5v. 5v times a 4v is a 20v squared. Okay? Then 5v times the 3 is next. So we have plus a 15v, right? 5v times 3 is 15v. Now we finished with the 5v, we're working on the negative 1. Negative 1 times a 4v is a negative 4v. And the negative 1 times a positive 3 is just a negative 3, or minus 3. So now we have 20v squared plus 15v minus 4v minus 3. We got to combine our like terms. The only two like terms right here are the 15v and the minus 4v. We combine those together, so we bring down everything else. So we have 20v squared. Bring down the 15v minus 4v, which comes out to be a positive 11v. And then we just bring down the minus 3. And there we have our final answer, 20v squared plus 11v minus 3. 2r minus 2 times negative r minus 7. Okay? Well, what I want to do is multiply all parts of my first parenthesis by all parts of my second parenthesis. Okay? So 2r times a negative r is a, well, negative 2r squared. Okay? Next one, we have 2r now times that negative 7. Well, 2r times a negative 7 is a minus 14r. Okay? Now we've done with the 2r. Let's use the minus 2. Minus 2 times the negative r is a positive 2r. And negative 2 times a negative 7 is a positive 14. Okay? So we have a positive 14 at the end there. Now we have to combine our like terms. Only like terms we see are the minus 14r and the 2r. So let's bring down everything else. Negative 2r squared. Minus 14r plus 2r is a minus 12r. So we have minus 12r right here. Then we have a plus 14 at the end. That comes down. Plus 14. Now we have our final answer. Negative 2r squared minus 12r plus 14. 3x plus 5 times 3x minus 6. Okay? Well, first thing I want to do is take all parts of my first parenthesis and multiply that by all parts of my second parenthesis. So 3x times 3x gives me a 9x squared. Then I multiply 3x by a minus 6, okay? And we get a minus 18x. Now I have 5 times 3x, so 5 times a 3x, right, dealing with 5 now, is a, well, 5 times 3x is 15, positive 15x. Now we have 5 times a negative 6, which is a negative 30, okay? So we brought that down. We already distributed multiplying all parts of first parenthesis by all parts of our second parenthesis, and so now it's time to simplify, combine like terms. Well, the only like terms I see are negative 18x and 15x. So bring down everything else. 9x squared comes down. But negative 18x plus 15x is a minus 3x. Then we bring down the minus 30. And now we're done. we have our final answer, which is 9x squared minus 3x minus 3. We have a negative 4x squared minus 5x minus 1 times 4x squared minus 6x minus 2. Okay? Well, what I want to do here is I want to multiply all parts of my first parenthesis by all parts of my second parenthesis. Just because there's 3 terms in each one doesn't mean we can't follow the same process. So, negative 4x squared times a positive 4x squared. All right, that's going to be a negative 16, but then it's x to the 4th power, right? X squared times x squared is x to the 4th power, okay? So, next one, multiply here the negative 4x squared by a minus 6x. Well, the negatives cancel, become positive, so we have a plus here. And then 4 times 6 comes out to be a 24. So we have 24 here, and that's x to the 3rd power. X squared times x is x to the 3rd. Then we have minus 4x times a minus 2. That's a positive here, positive 8, right? X squared. All right, so now what we have to do is multiply the negative 5x to all 3 parts, right? So negative 5x times a positive 4x squared. That's going to be a negative 20 x to the 3rd power. Then we have negative 5x times a negative 6x, which is a positive, right? Negative times negative is a positive, positive 30x squared, okay? Then lastly, we have negative 5x times a negative 2, which comes out to be, well, a positive 10x, okay? And then lastly, we have the negative 1 that needs to be multiplied to all parts. Negative 1 times a positive 4x squared is a negative 4x squared. Negative 1 times a negative 6 is a positive 6x. Okay? And negative 1, right? Negative 1 times the last arc here times the negative 2 is a positive 2. Okay? So now what we want to do is I like to, depending on our comfort level, but if you need some more time, which we'll do here, okay, I rearrange and put all my like terms next to each other, and they're pretty close, okay? So I start with the 4th power. I have a negative 16. I'll give a little space over here. So I have a negative 16x to the 4th power. I put a little dot showing that I brought it down. So that's the highest degree. Now the 3rd degree, so let's bring them down. Plus 24x to the 3rd. Brought that down. And the next x to the 3rd here is a minus 20. X to the 3rd. And then that's it for the x to the 3rd. Now we have our x squareds. We have an 8x. 8x squared. This marker's dying here, but I think you can still see it. And x squared. Bring down our 30x squared. Okay, we brought everything down so far. All right. And the last x squared is this minus 4x squared. Okay. Then from there, okay, from there we have just the x's, all right, plus 10x. Right there. Let's bring down the 6x and bring down the 2. So we should have everything down, every dot should be under every single term, write everything down. So now we can combine our like terms. Well, nothing else is to the 4th power, so we just have a minus 16 x to the 4th power. So now to the 3rd power. Well, 24x to the 3rd minus 20x to the 3rd is just 4x to the 3rd, right? Plus 8x squared, oh sorry, just, that's it. That's the only 2 3rd power. So we're good there. We have, that's just 4x to the 3rd. 4x to the 3rd power. Now we're going to bring down the x squareds. There's 3 terms here, all right? So what I like to see here is really, right, 8x squared minus 4x squared is just positive 4x squared plus 30x squared is 34, right? So we have plus a 34x squared here. Next, we combine our x's. We have 10x and 6x, which is 16x. So we have 16x right here. And then we have just a plus 2 that comes down. And this is the last probably move for the marker here. So our final answer here is negative 16x to the 4th plus 4x to the third plus 34x squared plus 16x plus 2. X squared minus 2x minus 8 times negative x squared plus 3x minus 5. Alright? Well, what I want to do is multiply all parts of my first parenthesis by all parts of my second parenthesis. Okay? So, x squared times a negative x squared, okay, is a negative x to the fourth power. Then x squared times a 3x, right here, is a 3x to the third power. Oops. I don't like that 3 that neat there. Excuse me. Third power. Now, we have x squared times a negative 5 is a negative 5x squared. Okay? Then from there, we multiply. All right, we finish x squared, then negative 2x. So negative 2x times a negative x squared is a positive, right? Positive 2x to the third power. Negative 2x times a 3x is a negative 5x squared, right? Negative 5x squared. Okay? Oh my goodness, not 5. Ooh. That's what I get for thinking about addition. It's 6. Common thing. Can't believe I did that, but it's negative 6x squared. I do that sometimes. Oof, I caught myself. So we have a negative 6x squared. Okay? Then negative 2x times a negative 5 is a positive 10x. Okay? So, lastly, we deal with a negative 8. Negative 8 times a negative x squared is a positive 8x squared. Negative 8 times a negative 3 is a negative 24, okay, 24x. And negative 8 times a negative 5 is a positive 40. So now what I'm going to do is I'm going to rearrange to have all my like terms next to each other. So the highest degree is the fourth power, so we just bring down the negative x to the fourth power. And I put a little dot showing that I brought that down. Now the third powers, we have plus 3x to the third right here, and I'll bring down plus 2x to the third as well. Nothing else to the third power. Now we bring down the second power, the square. Minus 5x squared right here. Minus 6x squared, bring that one down, and minus, or plus 8x squared. Then from there, we bring down our x's, so we have plus 10x, and then minus 24x, and then I'm going to bring down the plus 40. And I should now have every single term brought down. Alright, so now let me go simplify this, combine the like terms. Well, negative x to the fourth is element to the fourth power there. But the third powers, right, we have 3x squared and 2x to the third power. Well, we add those together, right, and that's fairly simple. 3x squared, and, 3x to the third and 2x to the third power, that's a 5. That one's a 5. 5x to the third power. Now let's go with the squareds here. Now this is how I like to see it, right? Negative 6x squared plus 8x squared is a positive 2x squared, plus a negative 5 is a minus 3x squared. Okay, got the squareds down. Bring with just the x's here, we have a negative 24x plus 10x, which is a negative or minus 14x, and we bring down the plus 40. All right. So now we have our final answer of negative x to the fourth plus 5x to the third minus 3x squared minus 14x plus 40. Minus 4m minus 4n times negative 6m minus 6n. Okay? So, what I want to do is multiply all parts of my first parenthesis by all parts of my second parenthesis. Now, be careful, there are two variables here, m and n. Okay? So, negative 4m times a negative 6m is a positive 24m squared. Okay? Then, negative 4m times a negative 6n is a positive, right? Still positive 24, but it's m times n. mn. Okay, now I finished with my negative 4n. Multiply now the negative 4n. Negative 4n times a negative 6m, all right, is a positive 24, all right, and that's m times n. Okay, and I'm going to keep it the same order as I did that one here, okay, because it really doesn't matter if it's n times m or m times n. All right, negative 4 times a negative 6n, right, is a positive 24, all right, and that's going to be n squared, okay, because both of them have the variable n. So now let's simplify, let's combine our like terms. Well, 24m squared just comes down, 24m squared. But now I have 24mn plus 24mn. That's a 48. So that's a like term, same variables, they're being multiplied, so we have plus a 48mn, okay? Then we just bring down here the 24n squared. And we get our final answer here of just 24m squared plus 48mn plus 24n squared. 8u plus 4, oops, there's a 4, not a v first, but it's 4v, I myself there, plus 4v, okay, times 6u plus 6v, okay. Well, what I want to do is multiply all parts of my first parenthesis by all parts of my second parenthesis. So 8u times 6u is a 48u squared. Okay? Now be careful, we've used in v's here, right? 8u times a 6v, again, is 48, but it's uv, u times v. Okay? Now I finished with the 8u, let's deal with the 4v. 4v times 6u, okay, that's going to be a 24. And it's v times 0, u times v. I'm going to put u times v, so it's the same order as the one we have written before, okay? And then, lastly, we have 4v times a 6v, okay, which again is a 24, but that is a v squared, all right? So now we want to combine our like terms. Well, our only like terms we see here are uv and uv, right? So let's bring down the 48 u squared, okay? But then we have 48 uv plus 24 uv. Combine those together, and we get a 72. So we have plus a 72 uv. And we bring down this last 24v squared. And there we have our final answer of 48u squared plus 72uv plus 24v squared. Simplify. Okay, simplify, and they write this. A plus B times C plus D. Okay? Well, we have A plus B times C times D. Now these are all variables. Well, the same rules still apply. We multiply all parts of my first parenthesis by all parts of my second parenthesis. So A times AC is just a AC. Then A times AD, right, is still an AD. Then B times AC is just, right, finish the A's, now we're on the B's, is just a BC. And B times AD is just BD. And that's actually it. There's no like terms that we can combine, right? There are combinations A times C, A times D, B times C, and B times D. And so this, in fact, would be our final answer, okay? Simplify. And then classify by degree and number of terms. Okay? And they give us this. 2x plus 3x squared times 4x minus 5. Okay? Well, first thing I do is I want to simplify this all the way. Okay, nothing I can do with that 2x, but this 3x squared I can distribute to both parts here. Okay, to both parts. So 2x comes down. Okay, 3x squared times 4x, right, is a 12x to the third power. Okay, then 3x squared times a negative 5 is a minus 15x squared. Okay, so now I'm going to rearrange this to have my highest degrees first, okay, and combine our like terms if there are, but there's not. So we have 12x to the third, that comes down right here. Then we bring down the minus 15x squared, right there, and then plus 2x. So now we have that final answer. We have this is what's simplified, 12x to the third minus 15x squared plus 2x. Now, our highest degree here is the third power. So we call that, we're classifying this as a cubic. Okay, cubic. And then we have three distinct terms here. It's a trinomial. So cubic trinomial. Trinomial. Yeah, I got it. Trinomial. Okay. So that's it. So quick recap here. Yes.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.